Okay, and we are back to page, this is 8 now. We're working with the very last of our nice little angles that are important. Well, they're all important. Nobody's not special. But these are the ones that really kind of have constant values that we can use. So pi over 6, if you would like to convert that into degrees so it's something you're more familiar with, pi over 6 is 30. If I take 180 degrees and divide it into 6, I'll get 30 degrees. If I take pi and divide it into 6, I get, well, pi over 6. So what we're doing with pi over 6 is we're going to be dividing the circle into 12 congruent arcs. I promise you I'm going to be trying to make them congruent. I'm not fantastically good at it, so we will see what we will see. I will do my very best. There we go. So we've got 12 Miss Coy congruent arcs there, and we're looking at them in terms of pi over 6. So here I've got pi over 6. Some interesting stuff is going to start happening now, is it not? Because what's going to happen right here at 2 pi over 6? I can reduce that, can't I? That's actually pi over 3. Didn't we just do that? We did. That was page 7. So I'm not going to worry about him so much. I'm going to worry about what happens at pi over 6. If I go another pi over 6, I get to 3 pi over 6, which reduces down to, pi over 2. That's a value I also know. And then 4 pi over 6. Oh, look what's going to happen. That's going to go down to 2 pi over 3, which, again, I don't need to worry about because we just did that. And this is 5 pi over 6. Okay, that one's important. That's something that's actually going to be a 5 pi over 6. Pi is 6 pi over 6. Right here is going to be 7 pi over 6, which I'm not going to be able to reduce. This one here is important. This is 8 pi over 6. That's going to reduce down to 4 pi over 3. Just did that on the last page. Don't care anymore. 9 pi over 6 is going to reduce to 3 pi over 2. 10 pi over 6. Okay, that's going to work down to 5 pi over 3. Just did it. Don't care. Well, I mean, I care. It's just not that important right now. And then 11 pi over 6, can't reduce that one, so he's going to be an important guy. And then the last one would be 12 pi over 6, and wouldn't you know, that comes down to 2 pi, and we've got the angles for that. So we have the points for all of the quadrantals, and we've got the points for everything that's a pi over 3, right? We got that. What we need is the stuff for pi over 6. So we're going to do the same thing we did before. Here's your radius. Radius is 1. Here is the x and y lengths. Here's your nice little right triangle. And this little angle here, which represents how far you go from the initial side to where the terminal side stops, that's pi over 6 or 30 degrees. So if you figured that we were working with 30, 60, 90 again, winner, winner, chicken dinner. 30, 60, and 90, radius of 1. And of course, now, here's the thing, they've rather switched places. So now the x value is root 3 over 2, and the y value is 1/2. Because the 30 and the 60 are in different places on the triangle. So again, you can look up the 30, 60, 90s on some of the links I gave you, but this is the same two values as the pi over 3, but they have switched places. So you're going to have root 3 over 2, comma 1/2, instead of the other way around. And again, as you go around the circle, pi over 6, 5 pi over 6 is going to have the same points, except that the root 3 over 2 will be negative, because x is negative in quadrant 2. 7 pi over 6, they're going to both be negative, because now I'm down in quadrant 3. And 11 pi over 6, the x is positive, and the y is negative because I'm in quadrant 4. So we're using the same two numbers as the pi over 3s, but they have switched places. And however you choose to remember that is up to you. Different people do things different ways. I don't think I'm going to go through that whole proof of the terminal point satisfying the equation because I pretty much just did that on the last page for these same exact numbers. So I'm not going to worry about that. So let's look at all the coordinates for the terminal points of pi over 6. And we're going to fill out this lovely little chart. So pi over 6, we had root 3 over 2, comma, 1/2. 2 pi over 6, remember, went down to pi over 3, and it was the other way round. 4 pi over 6 is 2 pi over 3, still the other way round, but with a negative x because quadrant 2. 5 pi over 6, got to switch them back because now we're working with the other one, but the x is still negative. So I'm going to stop right there. Okay, anything that's pi over 6, you're working with root 3 over 2 as your x and 1/2 as your y. Anything that's pi over 3, you're working with 1/2 as your x and root 3 over 2 as your y. So you're kind of switching them around. And the quadrant, again, is going to determine pretty much who's negative and who's positive. So over here, negative root 3 over 2, negative 1/2. 8 pi over 6 will go down to 4 pi over 3, so they switch. 10 pi over 6 is 5 pi over 3, so they're going to stay switched. And then 11 pi over 6, we are back to the root 3 over 2 being in front. And this is something you just kind of are going to have to remember which of the variations goes with which of the things. I think with pi over 6, I don't know, I just kind of remember it at this point. Remember that 3 pi over 6 is going to go down to pi over 2, which has a point of 0, 1. 6 pi over 6 becomes pi, which is, whoops, that's not true. It's negative 1, 0. 9 pi over 6 becomes 3 pi over 2, and that is 0, negative 1. And then when I get to 12 pi over 6, that's 2 pi, and that's 1, 0. So, again, we use the 30, 60, 90s on this one, but because now we're dealing with the 30-degree angle instead of the 60, they switch places. Yeah, you're just going to have to kind of memorize which one goes with which, and again, however you want to do that, go right ahead. And that is, I believe, everything for the pi over 6s, and yes, it is. And then we're going to, now in the next one, in the next video, the next page, page 9, we actually go and we put it all together, and you can see it all come together. It's kind of cool.